let's move on to our first section. So now, guys, I'm gonna turn off the camera in order to see the slides, okay? And now let's talk about how battery actually works, okay? A battery is like a small energy factory that store and release electricity when needed. This happens thanks to a chemical reaction inside the battery, which creates what we call electromechanical energy. Okay, so inside a battery, we have our anode and our cathode. Okay, and so let's see how does a battery storage and release energy. When we charge a battery, energy from an external power source like a charger force lithium ions to move from the cathode, okay, from the cathode to the anode through the electrolyte, okay. So electrons goes for the electric charge from the cathode to the anode, okay, and ion lithium batteries pass through the electrolyte, okay. Also, uh, also move, but they take a different path through an external circuit. Think of this like filling up a water tank. Lithium ion are the water, and we are pumping them from one side to other. Okay. When we use the battery discharging, the process reverse. Lithium ion move from the anode back to the cathode, and electrons flows through the external circuit, creating electricity to power a device or including a car. This is like letting water flows out of the tank to generate energy. So, in a simple terms, charging lithium ions move from the anode to the cathode, storing energy, and in the process of discharging, lithium ions move from the cathode to the anode, releasing the energy. Okay, this movement happens thousands of times during the battery lifetime. However, the battery slowly degrade because not all lithium ions move perfectly each time, and some get back stuck. Okay, so that's the when the the battery start to die. Okay, so each cell have a number of cycles. After this number of cycles, the cells start to die. So then we have cell formats. We have three different cell formats. First of all, we have the cylindrical cells that we can see in the picture. Then we have the prismatic cells that we can see in this picture. And then we can see the pouch cells, that is this one. Okay. Obviously, the cylindrical cells is the most common that we can see in a lot of electronic devices. So let's talk about cylindrical cells. Cylindrical cells are shaped like a tube. No, it's like a tube or a battery you would use in a remote control, like an AA battery. No, the positive terminal top, is on the top, and the negative terminal is on the bottom of the cell. Okay, so let's talk about the advantages and disadvantages. Okay, the advantages of the cylindrical cells, uh, they are very strong mechanical structure. Okay, they have very strong mechanical structure, meaning they are less likely to be damaged. Another advantage is easy to manufacture and cheaper than other types. Okay, so also good heat dissipation, meaning they don't overheat as easily. As you can see, when you put a lot of these kind of cells together, they have small gaps between them. So it's more easy to dissipate the heat. Okay? So let's talk about the disadvantages of the cylindrical cells. Wasted some space when packed together because of their round shape. No, so we say that an advantage is very easy to dissipate the heat, but it's also a loss of space. And then we have a lower energy density compared to other formats, meaning they are stored less energy for the same volume. Okay. Cylindrical cells are often used in Tesla vehicles because they are relief and cost effective. So now let's talk about the prismatic cells. Prismatic cells are box shaped and have a flat rectangular design. Okay, they are rectangular design. The positive and negative terminals are usually in the same side. Okay, on the top. You can see here the positive, and in the other side of the top is the negative. Okay, both are in the same side. Let's talk about the advantages and disadvantages. Advantages: higher energy density than cylindrical cells. Okay, meaning they store more energy in the same amount of space. Their rectangular shape allows them to be packed together efficiently in a battery pack, reducing waste of space. Okay, you don't have the waste of space that you can find in the cylindrical cells. Okay, with the prismatic, you don't have waste of space. Uh, they provide a good balance between performance, safety, and cost. Okay, disadvantages: they are more expensive. Okay, talking about the cost of these cells, they are more expensive to manufacture. If damaged, they can expand or swell, which reduce safety. Okay, so they have a relief valve here. So if they start to be damaged, the gases and fire could damage. Okay, prismatic cells are used in many electrical cars like BMW and Volkswagen models because they offer good mix of energy capacity and durability. Okay, and finally, then we can talk about Puch cells. The Puch cells is these ones. Okay, uh, Puch cells are the tiniest and lightest of the three types. Okay, they looks like a flexible packet. Also, they are flexible, similar to a sandwich pack. The positive and the negative terminals come out of the top like small metal stabs. Okay, so we can see here the positive, and in the other side of the cell, the negative. Okay, the advantages: the highest energy density of the three of these three formats of cells. They can storage more energy than the other ones. Okay, very lightweight, making them ideal for applications where weight is critical. Can be designed in different shapes to fit into specific spaces. Okay, so that's the reason why it's very common to see this kind of patch cells in mobiles. Okay, disadvantages: they are less mechanically strong and need external support like a hard case to protect them. Yeah, if you see this kind of cells in a vehicle, probably they can be stored in a hard case. Okay, because it's very easy to damage this kind of cells. More prone to swelling and damage if they are not managed properly. It's very easy to damage this kind of pouch cells. Pouch cells are commonly used in Nissan Leaf batteries and some high performance electric vehicles because they offer the best energy storage, but they need extra care. Okay? So, in conclusion, cylindrical cells are strong, durable, and cheap, but waste of some space. Prismatic cells have good energy storage and pack together well, but are more expensive. Okay? And the patch cells storage the most energy, but are fragile and require protection. Okay? Each format is used in different electric vehicles depending on what the manufacturer prioritizes: cost, safety, or energy efficiency. Now that we understand how energy is stored and the different batteries formats, let's move on to the next section. So now that we understand how a battery works, okay, let's take a closer look at three very important concepts: capacity, the energy, and the power. Okay, these terms are often confused, but they describe different things. Okay, they look, you can understand that they are very similar, but they describe different things. Okay, let's break them down one by one. Okay, first, let's talk about capacity. Uh, how much charge a battery can hold. This is the capacity. Capacity tell us how much electric charge a battery can store. We measure it in ampere hours. It represents the total amount of electric current a battery can provide over the time. Okay? Think of a water tank. If the tank is big, it can hold a lot of water. If the tank is small, it holds less water. Okay? Similarly, if a battery has high capacity, like 100 amperes hour, for example, it can store a lot of charge. If it has low capacity, like 10 amperes hour, it holds less charge. Okay. For example, if you have a battery with 10 ampere hour capacity, that means it can supply 10 amperes of current for 1 hour, or 5 amperes for 2 hours, or 1 ampere for 10 hours. The total amount of charge stay the same, but the speed at which you use it can change. Okay, so that's the capacity, the concept of capacity. Now we are gonna talk about the concept of energy, the total work a battery can do. Okay, while capacity tell us how much charge a battery holds, energy tell us how much work it can do. Okay, it's different. One is how much charge the battery holds, and the other is how much work it can do. Okay, energy depends on two things: capacity, the amperes hour, how much charge is available, and the voltage in the strength of the electricity. Okay, we calculate energy using the formula: uh, capacity per the voltage of the cell of the or the battery. Okay. Now let's go back to our water tank analogy. Imagine two tanks, one at ground level and one on the top of a tall tower. Both tanks hold the same amount of water, but the one on the tower has more energy because the water is at a higher position. And when released, it will hit the ground with more force. Okay? Similarly, a 12 volts battery with 10 amperes hour has less energy than a 48 volts battery with 10 ampere hour, because the 48 volts battery can provide electricity at a higher voltage. just like a water falling from a higher place can do more work. Okay? And finally, let's see the concept of power. How fast the energy is used. Okay? Power tell us how quickly energy is being used. It's measured in watts and calculate as a power equal to voltage per current. Okay? So let's go back to our water tank analogy one last time. Imagine you have two hoses connected to the same tank. One is thin, so water comes out slowly, and the other is wide, so water comes out quickly. Both hoses comes from the same tank, same total energy, but the wide hose delivers water faster, just like a higher power battery delivers energy faster. In electrical terms, a low power device, like a phone charger for example, takes electricity slowly. A higher power device, like an electrical car, uses electricity very quickly. Okay? That's why power is important. It tells how fast a battery can deliver energy. Okay? So now let's put everything together. Capacity. How much charge the battery holds, like the size of a water tank. Energy. How much total works the battery can do, like how much energy the water has depending on height. And the power, how fast the battery delivers the energy, like how fast water comes out of of a hose. Okay? A battery with high capacity can store more charge, but that doesn't always means it can provide a lot of power. For example, a phone's battery has a large capacity relative to its size, but it delivers power slowly. On the other hand, a car battery might have lower capacity, but provides energy at high power to move the vehicle. Understanding these three concepts is crucial when designing electric vehicles. Now, let's move on the next topic. Now, guys, we're going to talk about the C rate and the impedance. Okay? C rate, in easy words, it means C rate tells us how fast a battery is being charged or discharged compared to its total capacity. Okay? For example, one C rate means the battery will be fully discharged in 1 hour. Okay? Two C rates means it will be fully discharged in 30 minutes, and 0.5 C rates means it will take 2 hours to discharge. Okay. Uh, for example, here we have the example one C rate. We have 4 amps, 40 watts. Okay. 10 volts, 4 ampere hour, and 40 watts hours. So what happened if with this condition we pass with the half C rate? So we're gonna have the half of amperes. So we only have 2 amperes, and then the power is gonna be the half also. So we are gonna have 20 watts. Okay, but the other the voltage, the capacity, and the energy is gonna be the same because are the characteristic of the cell. Okay, so what happens if we double the C rate? We put two C rates. What is going to happen? We are going to have the double of the amperes, okay, of the current. So we're going to have 8 amperes. So it means we're going to have the double of the power. So we're going to have 40, if we have in one rate 40 watts, so we're going to have 80 watts. So the other terms are going to be the same, no? Because are the characteristic of the cell. So the voltage is not going to change, the capacity is not gonna change, and the energy that the battery can storage is not gonna change. Okay. So now let's talk about the impedance. Okay. The impedance is the internal resistance of the battery. Okay. Now this is like the friction inside the battery that resists the flow of the electricity. Okay. A battery with low impedance delivers power smoothly and efficiency. A battery with high impedance loses energy as heat, reducing performance. So, in other words, a battery with low impedance is a new battery, and a battery with high impedance is an old battery. Okay. As battery age, the impedance increase, meaning they lose more energy uh, and heat up faster. Okay. And then we have, for example, here, uh, our cell have the impedance, the electricity impedance, but also we have the chemical parts. So together are gonna give us our internal impedance. Okay, so the current, and this is our electrical charge. Guys, so now let's gonna talk about the state of health. Okay, the state of health is how good is the battery compared to when it was new. Okay, then we are gonna talk about the state of charge, that is how much energy is left. Then we are gonna talk about the depth of discharge, that is how much energy has been used. And then the full equivalent cycles, no? That is how many full charge cycles the battery has completed. Okay. And then let's gonna talk about the self-discharge. As you know, the battery has internal reactions inside, and the state of charge is gonna decrease. Okay. So let's start with the state of health. Okay. So how good is the battery? No, is the state of health. State of health tell us how much capacity the battery has compared to when it was a new one. Okay, a brand new battery has 100 of state of health. Okay, and then over the time the battery degrade and state of health decrease. No, this is gonna be our battery degradation. Okay, if a battery state of health is it means is an 80%, it means it can only hold 80% of its original energy. For example, if a car battery had 60 kilowatts hour when new, but only holds 48 kilowatt hours, its state of health is 80%. Okay. Battery lose state of health due to aging, high temperatures, and frequent deep discharge. Okay. So basically, the companies told us that when the battery of the vehicle is in the 80% of state of health, you need to replacement the battery. And why is that? Because they reduce the capacity and the power of the uh, of the of the vehicle. Okay. So what does it mean? So for example, if before to to be in this value, you could drive your vehicle 200 kilometers, but now at this value, you only can drive 100 kilometers. And also the power is reduced. So what does it mean? In other words, for example, if you go with your car at 100 kilometers per hour, then with the reduce of power, you only can be able to put your car in 80 kilometers per hour. So uh, your vehicle is gonna work, obviously, but the capacity of your vehicle is gonna be the performance of your vehicle is gonna be very reduced. Okay, it's not measurable; it's an estimation. Okay, so now let's talk about the state of charge. Okay, state of charge tell us how full the battery is, like a fuel gauge in a car, in a engine car. Okay, 100% of state of charge means the battery is fully charged. 50% of state of charge means the battery is half full. 0% of state of charge means the battery is empty. Okay, this use uh, this is useful because it helps us know how much energy is available before we need to recharge. Okay, uh, let's talk about the reality of uh, full electrical vehicles. Okay, so you have this capacity in electrical vehicles. This is the 100% of the state of charge, and this is 0% of the state of charge. But in full electrical vehicles, you only use from the 80% of the state of charge to 20% of the state of charge. Okay? So what does it mean? This is the real state of charge, 80%, that this is the higher value, and 20% of state of charge is the lowest value that you could use in your vehicle. In your dashboard, you can see in the 80% of state of charge, 100%, okay? And this is gonna be your 0%, okay? If that's this is what are you gonna see in your dashboard, okay? And why? Because in this area, in these two areas, uh, for the chemical of the cells, is the critical areas. We are gonna see uh, after these slides why these areas are critical. Okay, so don't worry. This is in a full electrical vehicles from 80 to 20, and in hybrid vehicles we can only use from 60% to 40%. Okay, in hybrid vehicles we are not gonna use this part of the capacity of our battery. And you are gonna ask why? It's because hybrid vehicles also have the support of the engine. Okay, so let's continue. We're gonna erase this in order to continue. Then let's talk about the depth of discharge. Okay, what is depth of discharge? Depth of discharge is how much energy has been used. Okay, depth of discharge is the opposite of state of charge. Obviously, it tells how much of the battery has been discharged. Okay, if for example, if the state of charge is 100% and you go to zero, the depth of discharge is 0%. No, battery is full. Okay. For example, if a state of charge is 50%, the depth of discharge is 50%, obviously. And if the state of charge is zero, the depth of charge is 100%. Okay. Uh, in order to not degrade the battery, it's better to use a smallest depth of discharge, the smallest depth of discharge. Okay. Then let's pass to talk about the full equivalent cycles. Is how many charge cycles has the battery completed. Okay, is the number of, for example, if you have 100% of the charge, you are gonna use uh, the the real cycles of the cell. But as I told you before, you are not using all the diff of the charge. You are only going from 80 to 20. So the diff of the charge is reduced. Okay. And so in order to know how many cycles you are gonna be available to use in your battery, you use the full equivalent cycles to know how many available cycles you have. For example, uh, 1000 cycles with a 50% of this charge means that you are only using 500 full equivalent cycles. Okay, so then let's talk about self-discharge. Self-discharge is the loss of stored energy over the time caused by parallel reactions. Did the self of the charge, it's gonna depends of the temperature and the state of charge of the battery. If the temperature is higher, uh, the cell of the charge is gonna be worse. Okay.